Hello students, so we'll be seeing this topic, relationship between zeros and coefficients of a polynomial from the chapter polynomial. Okay, so if suppose you have a linear polynomial like this ax plus b, so it can be written as ax plus b is equal to 0 and we can find the value of x. So that comes out to be minus b by a. So this minus b by a, which is constant upon the coefficient of a, so this will give us the value of x. This will directly give us the value of x. So similarly, since this was a linear equation, suppose if we have a quadratic equation, quadratic equation can be written in general form as ax square plus bx plus c. So you have a, b and c, which are real numbers. A and b are the coefficients of x square and x. So we can directly write the sum and product of the zeros. If suppose we take the zeros as alpha and beta, these are the Greek symbols. We say this, we call this as alpha and this is beta. So if we take these two to be zeros of this polynomial, so we can write the sum of these two zeros will give me minus b by a. So I can find the sum of the zeros by this ratio, which is minus b by a. Where is b? B is the coefficient of x and a is the coefficient of x square. So when you write your quadratic equation in the general form, so you can have the sum of the zeros, which is alpha plus beta, and that can be found directly by writing minus b by a. So this is one type of formula for you, and this product of those two zeros can be written as c by a. What is c? C is the constant term in this expression and a is the coefficient of x square. So we need to remember alpha plus beta is minus b by a, alpha into beta is c by a. We can have certain examples which is given here. Suppose you have 3x square plus 5x minus 2. So when you find the factors for this, you get 3x minus 1 and x plus 2. This we get after factorizing this. So from this we get x is equal to, we take 1 on the other side and 3, then it becomes x is equal to 1 by 3 or x is equal to minus 2. So you have two roots or two zeros, which is x is equal to 1 by 3 and x is equal to minus 2. So we can verify this now. Sum of its zeros. Now sum of its zeros, as we said, it is minus b by a, that is coefficient of x upon coefficient of x square. So if we add these two roots, you get minus 5 by 3, which is also equal to the this formula that we have, which is minus coefficient of x upon coefficient of x square, minus, that is coefficient of x, which is minus 5 upon 3. So this value is same. Product of its zeros, when you multiply 1 by 3 into minus 2, you get minus 2 by 3. Again this is equal to this formula, which is c by a, that is constant term upon coefficient of x square. So we have constant term is minus 2 and coefficient of x square is 3. So this is minus 2 by 3 and this is the same value that we get after multiplying both the zeros. So this is verified by the quadratic equation. So this becomes your formula when your equation is quadratic. So sum of the zeros is minus b by a, product of the zeros is c by a. Now suppose if you have a cubic equation. Cubic equation is of the general form as ax cube plus bx square plus cx plus d. Now since it is a cubic equation, so we expect to have 3 roots, and those 3 roots or zeros can be taken as alpha, beta and gamma. This symbol is read as gamma. So you have 3 roots alpha, beta and gamma. If suppose you have a cubic equation and there are 3 roots alpha, beta and gamma, so this is how we can find the relation between them. So relation between these 3 roots, that is alpha plus beta plus gamma, is minus b by a, and product of the 2 roots and their addition, that is alpha beta plus beta gamma plus gamma alpha, is equal to c by a, where a is the coefficient of x cube, b is the coefficient of x square. Okay, that is that's how we need to remember. Okay, and then c is the coefficient of x, d is the constant. So now the product of all the 3 is alpha beta gamma. Alpha beta gamma is minus d by a. So we have to remember this relation when your equation is cubic. Okay, so we had relation for quadratic equation, and this is the relation between the zeros when the equation is cubic.